All right, this is chapter 1, lesson 10, last lesson in the chapter, comparing real numbers. So, real numbers, a blank blank is a number that can be expressed as the ratio AB, where A and B are integers and B cannot equal 0. Again, bad things happen when you divide by 0 in math. Okay, worlds explode. Don't do it, bad idea. Okay, so in these two blanks, you're going to write rational number. So a rational number is a number that can be expressed as the ratio AB, where A and B are integers, and B cannot be 0. And blank blank is a number that cannot be expressed as a ratio AB, where A and B are integers, and B does not equal 0. Okay? In those two blanks, you're going to write irrational. Okay, so these are numbers like pi and the square root of 2. Okay, things that never end, you can't write them as a fraction. Right? Rational numbers you can write as a fraction. Okay, there can be repeating decimals, you can write those as fractions. All right, numbers that are not blank are called blank numbers. In those two blanks, you're going to write rational and irrational. So numbers that are not rational are called irrational numbers. The square root of any number that is not a perfect square number is a rational. The set of rational numbers and the set of irrational numbers together make up the set of blank blank. In those two blanks, you're going to write real numbers. So the set of rational numbers and irrational numbers together make up the set of real numbers. All right, let's go ahead and take a look at a couple of examples. Example number 1, name all sets of numbers to which each rational number or each real number belongs. The decimal ends in a repeating pattern. You can see 2525, it repeats. It is a rational number because it is equivalent to 25 over 99. I can rewrite it as a rational number. I can rewrite it as a fraction, so therefore it's a rational number. Okay? Square root of 36. Square root of 36 equals 6. So that's a natural number, a whole number, an integer, and a rational number. Okay? You can also use your ice cream cone, which we're going to talk about in a little bit, to help you with this as well. All right? 3 equals the square root of negative 7. Sorry, negative square root of 7 is approximately negative 2.64575131, blah, 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 blah. Decimal does not terminate, it does not repeat, therefore it is an irrational number. I cannot write this as a fraction. All right, so before we do the triad problems, I actually want to talk about the ice cream cone. Okay, so this is my ice cream cone. This is the real number system, including the cherry. Okay, so I start with my natural numbers. They're my smallest circle. Okay, so my number sprinkles down here, we're going to go ahead and fill these out together. So natural numbers are any whole numbers that don't include 0. So 1's a natural number. 1's a natural number. 2's a natural number. 3, 10, natural number. That's all, okay? Whole numbers include 0 and then all of my natural numbers. So 0 is a whole number, okay? Integers include positive and negative whole numbers. So they include whole numbers and natural numbers. Integers are anything that's negative whole numbers. So negative 1, negative 2, negative 3 would all be considered integers. Rational numbers are anything that I can write as a terminating decimal, a repeating decimal, or a fraction. Can be positive or negative. So 1.5, rational. 3/4, 0.009, 1.76, 5/6, 3/2, P over Q, 3.14, and negative 2/17. Those are all rational numbers, okay? Then I have pi. Pi is an irrational number. Okay? Again, it doesn't repeat. I can't write it as a fraction or a decimal that terminates or is a repeating decimal. Another example of an irrational number is the square root of 2. Really, any square root that is not a perfect square or any cube root that is not a perfect cube are usually considered irrational numbers. All right? So, now that you know this, I want you to go ahead, pause the video, try out the try it problems on the first page, A, B, and C, and when you're done, we'll go over the answers together. All right, for letter A, I have the square root of 10. Square root of 10 is not a perfect square, so therefore this is going to be irrational. For letter B, negative 2 and 2/5, this cannot be simplified into a whole number, so therefore it is a rational number because it's still a fraction, all right? Letter C, I have square root of 100, which really equals 10, so this is going to be a natural, whole, integer, and rational. Okay, so it's everything except the irrational one. Okay, it's a natural number because it's greater than 1 and it's a whole number because which includes 0, it's an integer, and it's a rational number because I can write this as a fraction. For comparing and ordering real numbers, you can compare and order blank blank by writing them in the same notation. So in those two blanks, you're going to write real numbers. You can compare and order real numbers by writing them in the same notation. Write the numbers in decimal notation before comparing or ordering them, all right? You don't have to do it in decimal notation. You can write them as fractions. I highly recommend you do change them to decimals. It will make your life easier, okay? All right, so I have a couple of examples to take a look at. The first example I have is number 4. Number 4 says fill in each circle with less than, greater than, or equal to make the statement true. Okay, so for number 4 I have the square root of 7 and 2 2/3. So I'm going to go ahead and look at the square root of 7. I'm going to approximate that to 2.6457, blah, blah, blah. It goes on forever because it's an irrational number. And then 2 2/3. 2/3 becomes 0.6 repeating. Okay? So I can look at these, and I have 2.64 and 2.66. That tells me that the square root of 7 is less than 2 2/3. It's a smaller decimal. Okay? For number 15, I have 15.7%. Okay, when I change that to a decimal, I have 0.157, and the square root of 0.02 gives me 0.141. Okay, looking at that, square root of 0.02 is smaller, so that means 15.7% is greater than the square root of 0.02. You can also draw it on a number line. Okay. For number 6, I want to order the set square root of 30, 6, 5 4/5, and 5.36 repeating from least to greatest. Okay? Verify your answers by graphing on a number line. Write each number as a decimal, then order the decimals. So square root of 30 is approximately 5.48. 6 is, of course, 6. 5.45 equals 5.80. And 5.36 repeating is approximately 5.36, which I round to 7, so 5.37. Okay? Then I can go from least to greatest. So the smallest one is my 5.36 repeating. So this is the first one. And then next would be the square root of 30, then 5.45, and then, of course, 6 would be last. Okay. that I can graph those on my number line. All right, there are a couple of try problems. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So the first one I have is letter D. Letter D says the square root of 11 and 3 1/3. Well, square root of 11 is approximately 3.3166. 3 1/3 is 3.3 repeating. Okay, so looking at these, 3.31 is smaller, so that means square root of 11 is less than 3 1/3. For letter E, I have square root of 17 and 4.03. Well, square root of 17 is approximately 4.03. I'm sorry, 4.123. For letter E, square root of 17 and 4.03. Square root of 17 is approximately 4.123. So that means square root of 17 is bigger, greater than. Letter F, square root of 6.25 and 250%. Well, square root of 6.25 is approximately 2.5, and 250% equals 2.5. So they are equal to each other. This is actually. For letter G, it says order the set -7, negative square root of 60, -7 7/10, -66 ninths. From least to greatest, verify your answer by graphing on the number line. So -7, of course, is super easy to graph. I'm going to go ahead and graph that. Negative square root of 60 is approximately -7.75. -7 1/10 equals -7.70. -66 ninths is approximately -7.33. So there's -7. -7.75 is right here. That's the square root of negative square root of 60. Then I have -7 and 7/10 right there. And then -7.33 is about right there. That's -66 ninths. So I'm going from least to greatest, so the smallest to the biggest. I'm dealing with negative numbers, so these are actually smaller. So my answer is going to be negative square root of 60, -7 and 7/10, -66 ninths, and then -7 is my last one. And that is the end of Chapter 1, Lesson 10. It's also the end of Chapter 1.